So in this video, we'll continue with very important properties. There are two of them. Property 1 says that each of the numbers P1, P2, Pn is between 0 and 1. So for the die that we looked at in the previous video, it means that the probability of an outcome is going to be between 0 and 1. That's one. The property 2 says that when you add all these probabilities, you should get 1. So this is a check. So let's look at this example. A group of 141,000 college freshmen were asked a question about the intended measure, and this table, the reference for it is there, and this is from your textbook as well. So determine the probability distribution for this experiment. In order to figure out this probability distribution, it's like you have a frequency. We need to see, for example, you can call this, let's say, 1. So if you want the probability of 1, which is the students intend to measure in arts and humanities, it's going to be that 14,241 divided by the total, which is 141,000. Okay? And we can do that to all of them. So I would recommend maybe pause the video and you do this for each one. The numerator is going to change. So 21,009. And the bottom is going to remain as 141,000. And you get your numbers. So 0, 1, and 1. So as you see, this P1 here is between 0 and 1. So yes, it does meet here for the second question, the fundamental property 1, yes. So fundamental property 1 is good. And we keep going. So what does this probability number mean? If you multiply it by 100, right, you get 10.1%. So this is the likelihood of a student intending to measure in arts and humanities, 10.1%. Right. So if you take engineering, for example, let's call it 2, 3, 4. So this is P4, 18,471, 141,000, and all right. So we get 0.131. That means 13.1% I intend to measure in engineering. Then you will add these numbers down. All the numbers you get, you'll add them down. You should get 1. And the second property is satisfied. So the additional principle, suppose that an event E consists of the finite number of outcomes, then the probability of E is the sum of this finite, the probability of these finite number of outcomes. All right, I think probably we'll, all right, let's explain a little more of these examples, then we'll move on to the next one. So this is an important thing to know with probability, because we did it with sets. The inclusion-exclusion principle, let E and F be any events, then the probability of E union F, right, equal to the probability of E, event E, add probability of event F, subtract the probability of E intersection with F. If particular, or in particular case, if E and F are mutually exclusive, then this thing is gone. It's zero, right? And we saw that with sets. If the two sets are disjoint, they have no common elements, then the intersection is zero. Okay, so we're going to look at this example. So follow the formula this way, unless you know it's this case, right? So you can say maybe this is a general, right? And this is a special case if they are mutually exclusive, right? So a factory needs two raw materials in order to operate. So you know, some word problems, some sentences are just extra, but this one is kind of important here. So because it tells us that this factory, in order to operate, it needs two raw materials. The probability of not having an adequate supply of material A is 0.05. So if I want to follow with this E and F, you can do A and B. It's best if you do A and B, right? But if you want to see it in these terms of that are stated there, if you do, let's write it. Sometimes, you know, we do P for probability. So if I write P, I also mean probability. Yes. This book use PR. So if you put A and B here, you're just gonna replace some E and F for that. It's similar, right? So same thing. So for the material A, probability is 0.05, whereas for the probability of not having B is 0.03. So let's see both of them. The study determines that the probability of shortage of both A and B is 0.01. All right, so we calculate this and get 0.07. So 7% to be short. All right, of these materials. What portion of the time can the factory operate? So we're interested in the operation of the factory and see its reliability, right? And if the downtime is 7%, then the uptime should be the complement. So 100% minus 7% is 93% to operate. All right. So that's the goal to find. Thank you. We'll continue in the next one.